Hello friends, welcome to this video. Today we are going to discuss p-n junction, formation of p-n junction diode or p-n junction in case of semiconductor laser. We are going to discussing about the semiconductor laser, and in that p-n junction, how p-n junction diode is formed in case of semiconductor laser, that we will see in this video. In last video I was discuss about the population inversion in case of semiconductor laser. Population inversion, what is population inversion and how it is achieved in case of semiconductor laser, that we have already discussed, and in this video we are going to discuss the p-n junction, formation of p-n junction. So if you look at this diagram, this is a band structure of a semiconductor. As you know that there are different types of bands in case of semiconductor laser. Different types means valence band and conduction band. These are the holes. If you look at these circles inside this valence band, these circles are called as holes, and these are the electrons inside the conduction band. So majority charge carriers in case of valence bands are holes in case of p-type material, and this is the n-type material. These are the electrons, they are large in number. So this is actually p-type. This is a band diagram of p-type material, instead of this p, it is actually n-type material, sorry. This is n-type material, and this is the band, conduction band, and this is valence band of n-type material. So in case of n-type material, there are large number of electrons inside the conduction band, and few number of holes inside the valence band. So these are the two band structure. This line, it is called as Fermi level. This is about for n-type material, and this is for p-type material. The Fermi level, it is a reference level. Actually, what is Fermi level? Fermi level, it is a level at which there are 50% probability of occupation of electrons at any temperature. That level is known as Fermi level. So actually the Fermi level, it is a reference level. In case of p-type material, it is just above the valence band. In case of n-type material, it is just below the conduction band. So for pure intrinsic semiconductor, it is the midway between the p conduction band and valence band. So this is a reference level. If we join p and n-type material, what will happen? Up to the equilibrium is attained. Due to that, equalization of Fermi level takes place, and the Fermi level of a p-type material goes upper side, while this n-type material goes down. And when equilibrium is attained, two levels will be at this Fermi level will be at same level. This is analogous or similar to the, if we are having two containers filled with the liquid of unequal height, and if we connect them, what will happen? The container which is having upper level, the upper level of liquid goes down, while which is having a lower level, that level goes up. So analogous to that, if we combine p and n type of material or junction, p and n type material, the Fermi level of n type region goes down, while p type material goes up, and equilibrium is attained, and both the levels will be at same height. If you look at this diagram, the Fermi level is at of same height. What will happen if we combine p and n type material? The first thing is majority charge carriers inside the n-type region. Inside the n-type region, there are electrons are the majority charge carriers, while in case of p-type material, holes are the majority charge carriers. What will happen if we combine there is the electrons are larger in case of n side and smaller in case of p side, that electrons in n type are known as majority charge carriers, while electrons in the p type materials are called as minority charge carriers. Similarly, if you look at the p type material, there are holes are the majority charge carriers, while electrons are the minority charge carriers. So the electrons are larger in number on the n type and smaller on p side material. Similarly, holes are larger in case of p type material, they are majority charge carriers in p type material, while smaller on n side, means in case of n side the majority charge carriers are electrons and minority charge carriers are the holes. So there is a concentration gradient of the charge carriers inside the semiconductor region actually. So this, due to this, they diffuse across the junction. What will happen? The electrons inside the p region moves towards the p side, while holes inside the p region moves towards the n type material or n region. Due to that, electrons combines with the holes and the depletion region is formed nearer to the junction. The electrons and holes diffuse in opposite direction and recombines the near to the junction. Therefore, the narrow region around the junction is left with the immobile impurity atoms and neutral host atom. So due to the this formation of a junction, the electrons inside the n region cannot goes inside the p type material, and holes inside the p region cannot cross that junction if they are not having a sufficient amount of energy to cross that junction. So this is the formation of depletion region. The immobile ions are negative on p side, that is called minority charge carriers, and positive on n side. These layers of opposite charges create the potential barrier for the diffusion of majority charge carriers. Means the depletion region or potential barrier is created in between the p and n type material. So the mutual displacement of the energy levels on the both sides, due to the displacement of the energy levels on the both sides, this is a and n type, there is a bending of a junction takes place. This is a at this side. If you look at the diagram, this is a bending of this depletion region. So these are the holes, this is the p type material, and this is the n type, n region actually of semiconductor. These are the electrons, majority charge carriers. Due to that, energy level shifts down, and in this case energy level, displacement of energy level takes place. So that's why these regions are bent. This is bending of this depletion region, it takes place. Now what will happen if we increase the concentration of the doping concentration of the p and n type material? Due to that, what will happen if we increase the further doping concentration of p type material? The conduction band at high doping concentration, the Fermi level of p region below the valence band edge. This is a Fermi level of p region. This is if we increase the doping concentration, the Fermi level of this p type region is below the valence band edge. This goes to the below the valence band edge, while due to the increase the doping concentration of n region, this Fermi level goes to the above the conduction band edge. This is conduction band, this is valence band. If this will happen only if we increase the concentration of the doping concentration of the p and n region. Now the probability of stimulated emission is occurring, it is very low at thermal equilibrium. So what will happen? This is the D region. If we look at the diagram, this is the D region. Now if we connect the PN junction diode, in a case of forward bias, what will happen? The electrons or holes, electrons from P region, electrons from the N region combines with the holes. They will attain the energy. They will try to cross the junction. Electrons from the N region goes towards the P region, and in this depletion region they recombine with the holes, and due to the recombination of whole electron hole pair, the energy is emitted, one photon. If you look at the this h nu, this is the energy of a photon which is emitted inside this region. So the emission of photon takes place in this much region. If the electrons inside this region, that is the N type of material, have sufficient energy, and holes, this recombination takes place in this region, and with the emission of photon. So this will happen in case of semiconductor laser, and photon is emitted inside this region. So in this region there is a large number of electrons, electrons, and these are the large number of holes. They combine. This is the condition for the population inversion. Population inversion is achieved means there are large number of electrons and large number of holes, and they recombine in this region. So this is called as a depletion region, and the photon is emitted or energy is emitted. So this is the working of emission of photon in case of P and N type material, and this is about what will happen if we combine P and N type of regions in case of semiconductor material. Thank you. What will happen per minute? Large concentration of holes within condition of population inversion. Now the zone over which the population inversion occurs is called as inversion region or the active region. This is the condition for population inversion.